Our topic today is now the ratios of the triangles in the vectors topic. Let's say this figure is shown to you. The first point is if the two triangles are similar. Similar means in this figure, this AB is shown parallel to this CD. So we know that this triangle OAB is similar to this triangle OCD because they have a common side in between these two. And with the similar figures, we can prove it that this angle is equal to this angle is equal to this angle, and the third side is common. So three angles are two sides and one angle. This is the property of the similar figures. So when they are similar figures, then the ratio between these two triangles will be triangle OAB over triangle OCD is equal to OA over OC whole square or OB over OD whole square or AB over CD whole square. So any of these sides are shown to us and they are similar, then the ratio is the square of the ratio between their respective sides. Now we can calculate it from this part that OA is P over OC is 3P and then it is square. P and P cancel out. So 1 over 3 square or it is equal to 1 over 9. So whenever the figures are similar, then the ratio is the square of the ratio between their respective sides. Now for the second part, let's say we join this B with C. Now we are going to find out from this figure O, B, C. This is going to join with this. Here is the point AB. This B is the common vertex between these two triangles OAB and ABC. So when they have a common vertex, if you draw this perpendicular from this height, this is the common height between these two triangles. This height is for ABC and this height is also for OAB, where OA is basically denoted by P and this is denoted by 2P. So when it is having a common vertex with the sides OAC on the same line, then the ratio between these two triangles OAB over triangle ABC is equal to half. The base there is OA and height is H. Base there is AC and the height is H. So it is basically the ratio between their respective sides. So OA is basically equal to P and that thing AC is basically equal to 2P. P and P cancel. So it is the ratio between these two triangles is half there. So this means that they have a common vertex B with the collinear base as OAC there. And collinear means what? They lie on the same straight line. So when they lie on the same straight line, you are going to find out the ratios of these two triangles, then it should be equal to OA over AC. So this is the second part of that they have a common vertex between these two. The third point is there that if we draw this triangle, from the same vectors topic, A, B, C, and D, where BC is common side between these two triangles. Of these two lines are parallel to us. So AB is basically equal to, shown there, equal to Q, and CD is basically equal to, shown to you as 3Q. So it is basically shape of this trapezium where these two sides are parallel to each other. Then we know that this is the height of this triangle, and if we draw this height, then this is the height of this triangle. So it is basically, if we calculate it with respect to this part, that it should be equal to ratio between the triangle ABC over triangle BCD, then it should be equal to half into AB into height over half CD into height. So AB is basically equal to Q and CD is basically equal to 3Q. So it is the ratio between these two triangles is 1 over 3. So when this trapezium shape you are going to form from this figure, then the ratio between their parallel sides will be the ratio between their respective triangles. So it is basically the ratio between AB over CD. These are the two sides which are parallel to each other. So when these two sides are parallel to each other and they have a common vertex between these two, then the ratios between this will be AB over CD there. And the third part, this is third part of that. So when they are similar, then the ratio between them is the square of the ratio between their respective sides. If they have a common vertex with other two sides are collinear, so one side is collinear on the basis of that, then the ratios is between OA and AC. And if they are forming a trapezium where the two sides are parallel to each other, then the ratios is basically the ratio between their respective parallel sides there. So this is the rules for this ratios of the triangles in that vectors topic.